So we're going to go ahead, if Donna Ellis is on, hopefully, we're going to have her talk about what is new with IPM in Connecticut. She's from the University of Connecticut, and this is a crop protection pest management extension implementation program. So Donna, if you're on, you can go ahead and get started.
Thanks, Steve. Can you hear me okay?
Yes.
Great. Appreciate being a part of the third online conference today. Just like to fill you in on our Connecticut IPM program. We've been very pleased to have the support of USDA NIFA the last couple of years with the Extension Implementation Program. Our team included 9 members for the last 3 years. This year we had some transitions with retirements and some other moving about, so we're currently replacing 2 of those members, but we had a very productive year. This is a screenshot from our IPM website, which is ipm.uconn.edu, and we have a lot of educational resources there that we try to promote for our growers, the general public, and others with interest in IPM. In the past 4 years, the IPM program team has directly trained almost 38,000 people in IPM practices. Our training programs and educational outreach represent 290 businesses statewide. We've also provided training to about 6,000 other participants regarding pest management and decision-making and safe pesticide use and handling. There have been about 2,300 plant pest samples diagnosed. So we've had a very, very busy couple of years, and really enjoy having our team work together to help train many individuals and businesses in Connecticut on IPM. Next slide, please. Just want to highlight a few activities with some of our members. Mary Conklin does our tree fruit and small fruit and berry IPM training. She does a lot of full season programs, many messages that she sends out 24/7, it seems, especially when there are pest situations that are fairly urgent, trying to give information to the growers. She does a lot of work trialing brown marmorated stink bug and spotted-winged Drosophila traps and lures, trying to increase efficiency of the traps, trap counts, first detections, and really has been very successful learning the growers when these pests are present on the farms. The picture on the upper right is Mary Conklin and myself at our annual Connecticut Agriculture Day at our capital. There's a lot of outreach that goes on. We interact with the legislators and acquaint them with the activities that we've had during the year with the IPM program. We have a school IPM coalition and a school IPM program that goes on. We focus on exterior IPM projects. These are usually the athletic fields, turf, landscapes of the K-8 schools. You may be aware that Connecticut is one of the states for which there are no pesticides allowed on K-8 grounds. That's indoors and as well as outdoor grounds. So we do a lot of workshops. We have annual workshops. In the past 7 years, we presented 10 workshops. We rotate to different schools each year, so to bring in the school grounds managers, the boards of education, the facilitators, trying to promote practices and ways that they can improve their IPM practices to enhance health of turf and also the landscapes. The lower section of this slide, you can see Joan Allen, who is working on a plant pest specimen. Joan diagnosed 764 samples just this past year. A lot of these samples were diseased plants, but she also provides identification and recommendations for insects and weeds. Joan is one of a group of states that have the plant sample submission app, where people can upload images and get assistance with their IPM needs. Next slide. Thank you. Leanne Punt is our greenhouse and perennial plant IPM extension educator. She continues to work with wholesale and retail growers with season-long IPM training. She has been very successful introducing and encouraging biological control for greenhouses. particularly with beneficial nematodes and some other biological control agents. She does an annual summer conference, bringing in the growers and giving them updates on some of the new techniques and new technologies for greenhouse IPM. So a lot of success there with her program. She's also been encouraging nursery and perennial growers to embrace biological control, and that is really starting to take off in our state as well. I'm involved in the nursery IPM program as well as invasive plant IPM. I've been conducting full season training at a number of our larger wholesale and retail nurseries around the state. We started a new landscape and nursery update this summer where we sent out and also post on our website seasonal and relevant pest messages and other information that growers may want to have. We are very involved with the grower meetings that go on during the year. There's usually a winter nursery and landscape conference, a winter groundskeepers conference. With invasive plant work, we do a biennial symposium, and the 2016 symposium that we had was again sold out with over 500 people attending. We provide a lot of information on invasive plant identification, management, and the use of alternatives. We do biological control for invasive plants, including myelominate. The picture in the middle right is one of the myelominate weevils that we use, and we also continue with purple loosestrife biocontrol. And then just to wrap up our team, Anna LeGrand continues her work with biological control. She's active with turf and landscape IPM and urban agriculture. She's been looking at Typhia wasps and their role in providing white grub biological control, and has more recently been looking at natural enemies with specialty cut flowers, and also natural enemies in crucifers to try to encourage that buildup of the population.
Okay, thank you, Donna. I really appreciate that update. We're going to move along to Olivia Sanders, and this is a Northeast SARE project on weed control and low input or organically grown wild lowbush blueberries, and she's with the University of New Hampshire. So Olivia, go ahead.
Sure, thanks, Steve. Yeah, this was a project looking at weed control in wild blueberries. Our main target weed is little blue stem, which is a grass that's present throughout Maine and New Hampshire. And the primary control for little blue stem is hexazinone, which is the active ingredient in Belpar. And that product is mobile in water, and it can travel through the soil. So in addition to that, lowbush blueberry fields are often shallow, very sandy, low in organic matter. And so the prevalence of the hexazinone in our water table is increasing in those areas where there is a lot of blueberry production. And then additionally, there's not a lot of control options for organic growers. So there are many benefits to finding a secondary control for the little blue stem that is not the hexazinone, both for organic growers, but also for anyone looking to reduce their use of hexazinone in their production fields. So we had a first study we did before we conducted this SARE funded project, and that's the photo here. You can see on the left side of this photo where we applied sulfur. There's pretty good grass control of the little blue stem, and on the right where we didn't apply anything, you can still see those grasses heading out. And you can move to the next slide. So our primary question was, will application of sulfur work as an alternative control method for little blue stem in lowbush blueberry production? So we implemented a replicated trial in the field, and we applied sulfur in the spring. We had a really low treatment where we tried to get the soil pH down to 4, 4.5, and then 4 with a fertilizer, and then a control where we didn't apply anything. We replicated this 4 times, and we had 2 sites where we did this. The fertilizer was an organic ProGrow fertilizer, and after we applied the sulfur, we took weed counts for the following 3 seasons in the spring and fall, and we measured the number and the size of the little blue stem over time. And you can go to the next slide. What we found was that there was a general increase in the little blue stem over time, no matter what the treatment was. So we didn't get, full control with using the sulfur to control the weed, but we did see some effect from the sulfur compared to the control. So for the organic growers that decide to do nothing, that's not going to work, because the weed will continue to grow. And then we also found that the plots that received the nitrogen fertilizer, they were more similar to our control. So the weed was outcompeting the blueberry for that fertilizer and benefiting from that fertilizer. So if you are a grower, you have this weed, we would recommend that you avoid applying any fertilizer until you get the weed under control. And we didn't see full control, likely because we never reached the target pH of 4.0. So the soil probably had a higher buffering capacity that we didn't realize. So applying a little more sulfur might have resulted in better control. And basically the takeaway from this is that can be one tool to use if you have a small infestation of little blue stem. But if that field, like the photos shown here, if that field is pretty well covered in little blue stem, you might need to go back to a chemical control and use the sulfur as an additional tool moving forward. And that's
okay. Great. Thank you, Olivia. It reminds me of some of the work that I've seen on corn gluten meal, trying to give the competitive advantage to the crop over the weeds. So really interesting work there. We're going to move along to hear from Andrew Keller from Vista View Farms, Maryland. And this is a Northeast SARE project entitled Use of Rate of Gain to Determine Anthelmintic's Need in Blue Faced Leicester Lambs. So, Andrew, I probably butchered that title. Please correct me, but go ahead.
You were pretty close. Can you hear me?
Yes.
Thanks for this opportunity to share this little bit of info about our project. It's using real-time rate of gain.
Andrew, can I just interrupt you a moment? On my end, your sound is really low, so I don't know if you can be closer to your microphone and so we can hear you better.
How about now?
It's a little better. Just shout.
Okay. To determine anthelmintic needs for pasture-based blue-faced Leicester lambs here in Maryland, our project was made possible through the Northeast SARE Farmer Grant. Next slide. Little background. We were interested in doing this project because the parasites, specifically worms, are a major problem for lambs. Not only can they reduce weight gain, but their ability to thrive. But often the homunculus worm is our main problem here in Maryland, and it does prove to be lethal at some point for the lambs if they have a high enough parasite load. Lambs can be treated with anthelmintics to kill the parasites, but like antibiotics, there are a limited number of classes of anthelmintics for us. There's only 4. Also, like antibiotics, parasites can become resistant to the anthelmintics and reduce their effectiveness. Farm animals are often treated in groups when a veterinarian comes out, or they will all receive a vaccination. So historically, protocols have recommended drenching the entire flock at specific times, such as around lambing time, when the parasite load, when parasites seem to want to build up in the ewes because the ewes have been putting so much into the growth of lambs. And then for the lambs at weaning, because weaning is semi-stressful time for them. And then the other old rule of thumb was on a every 3-week schedule throughout the forage growing season. So more recently, there's been a focus on preserving refugia, which is illustrated in the upper right figure there. This is done where farmers and veterinarians need to select only a portion of the animals. Those that really need to be drenched will receive anthelmintics. This allows the parasites to still be susceptible to anthelmintics and remain in the gut for the The current gold standard for determining which animals need to be drenched is known as Flamacha. The card's there on the lower left-hand of the slide. This evaluates the membrane around the eye and is a valuable tool, but can be very time-consuming for larger flocks, and also it's physically challenging. So we wanted to know if we could use rate of gain of individual lambs to quickly assess the needs for drenching. To do this, we used electronic identification in the lambs and a scale and software system that could calculate the lamb's rate of gain in real time in a matter of seconds. Next slide, please. We were very encouraged by the results. 3% of the time when determining by Flamacha that the lambs needed to be drenched. The rate of gain measure also indicated that the lambs needed to be drenched. We also found that using the rate of gain was less time consuming. As with many projects, we found that we should do some things a little differently. We're interested in looking at our data to evaluate the rate of gain cutoff, adjusting that to ewes versus wethers or rams. And we think that every 2-week schedule would probably be a little bit better for lambs and the producer than every week. The drawback to this approach is it does require a significant financial investment into the software and the electronic IDs for small and medium farms. It also requires farms to take into account other lamb issues such as coccidiosis, weather issues such as rain, because when you're running the lambs through and weighing them to use the weight as part of your determining factor, the fleece soaks up the water and then you get it off weight. Not only for that week, but you get it off weight for the following week. Like I said, we're very encouraged by what we found with it, and we'd like to probably do another year of trial.
Great, thank you, Andrew. This is really interesting. You know, the things that we see in the crop plant world there's some relationship there in the animal world as well. So it's interesting to see your work and to hear about what you're kind of experiencing too, and see that dynamic between the two kind of areas. So thank you. If there's some time for questions, we'll take those at the end. We're going to get to our last speaker this morning. This is Mary Barbercheck, and she's from Penn State University. This is a Northeast IPM Center project entitled Going Underground, Conserving Insect-Pathogen Fungi for Biological Control. So Mary, go ahead.
Thanks. Over the past several years, over several projects, we've been assaying soil for insect pathogens as a component of biological soil health, and to understand how to conserve biological control in the soil in different agricultural production systems. And one organism that we commonly find is this fungus, Metarhizium, which has been studied as an insect pathogen for many, many years. And the way that it works is there are spores in the soil that adhere to and germinate in a susceptible insect host, and what you end up with is like the fuzzy insect on the my upper right. which has been infected and producing spores. More recently, it's been discovered that this fungus, as well as being an insect pathogen, can grow in association with plant roots, and it can actually grow into plant roots. And it is, when it does that, can be a plant growth stimulant or have a positive effect on plants. And even more recently, it's been discovered that this fungus can grow out of infected insects and transfer nitrogen into plants. And so we're very interested in what this fungus is doing in some of these systems. And so currently I'm involved in an OREI-funded project that's examining the effects of cover crops grown in monoculture and mixture on several functions in an organic wheat, corn, soy rotation. And so we're looking at we're taking a closer look at what this fungus is doing there. Next slide, please. And so what we found so far, okay, so one of the objectives of that larger project is to determine if cover crop mixtures have greater benefits for ecological functioning, for benefits to crop production compared to monocultures. And what we've found is for this fungus, there is no effect of cover crop diversity on our, where we detect this fungus. However, we did find some plant-associated effects. Where Austrian winter pea is grown as an overwintering cover crop, we find higher amounts of this fungus in the soil. And where we grow canola as a monoculture overwinter cover crop, we find lower amounts of this fungus in the soil. We also find a negative relationship with the percentage of cereal rye in mixtures. And so that tells us a little bit about the effects that these cover crops are having on the abundance of this fungus in the soil. We also, when we compare the cash crops, soybean, maize, and wheat, we find the highest amounts in corn. And we're also looking at soil characteristics, and we find some of the soil characteristics that are positively associated with detection of this fungus are active carbon or labile carbon in the soil. Explains a lot of the variation in where we find this. Clay content is positively associated. And from our initial analysis, it looked like sulfur was also positively associated. Sulfur concentration in the soil was positively associated. However, when we look over a range of sulfur concentrations, we find that this is a quadratic relationship. It's positive in the low sulfur concentrations, but once you hit a certain threshold value, you start having negative impact of sulfur on this fungus. And that makes sense because we know that sulfur is a microbicide. And we also find a weak positive interaction with electrical conductivity, which is an indicator of overall soil fertility. Next slide, please. So we wanted to take a closer look at this relationship with the cover crops, since we saw a negative relationship with cereal rye and a negative relationship with canola and positive with Austrian winter pea. So we expose seeds of those plants and plant them out in the greenhouse and look at effects on plant growth and whether we can recover endophytic growth of the fungus from these plants. So can we take a plant section when we've grown these plants from a seed that have been exposed to the fungus, can we then re-isolate that fungus from other places in the plant? And so across the bottom you see sections from control plants, plants that have grown without the fungus on the seed, and then plant sections, leaf sections, and root sections from plants that, those are corn plants that have been grown when the seed has been exposed to the fungus. And so what we find with the cover crops is that we cannot recover endophytic metarhizium from the roots or leaves of cereal rye or canola, and those are plants that we saw low abundance of the fungus. And we couldn't recover endophytic growth of Metarhizium from Austrian winter pea leaves, but we could from about 1/3 of the root sections. What was especially interesting that even though we couldn't recover fungus from cereal rye or canola, we had plant growth enhancing effect of exposure of the seed to fungus on those, and they also had higher leaf greenness if they had been grown from seed exposed to the fungus. We did not see the same plant benefits in Austrian winter pea. And we did test corn, and corn is readily infected. About 100% of our plants become infected, and we can isolate again from roots, stems, and leaves, but we saw no plant growth enhancing effect on corn. And so that's what where we're at now. These experiments are still in progress, and we're continuing to isolate this fungus from the field and looking at effects in the greenhouse on plant effects, and we're doing some molecular analysis to look at gene expression in exposed plants.
Great, thank you, Mary. This is really interesting, especially when you talk about, going underground. I mean, that's just an area that we don't always think about because we don't see it. So I think this is really important work to be doing. So we've got about 5 minutes left, and I know we have a Q&A question to answer, and there also has been some good chat discussion. I'm actually going to turn this over to Jana. So Jana, if you could wrap this up. But one thing that I would encourage before I go is keep the discussion going. And if there was a connection, if you saw something, please make sure you reach out to another individual or contact us or let us know how we can help in this, because I think this is really important. But I'm going to sign off, and I'm going to turn it over to Jana. Thanks again, everyone. This has really been great.
Okay, thanks, Steve. All right, so Peter, Jens, if you're still on the line, there is a question for you from Cesarina Cora. And she said, what was the Google site where the BMSB information and incident map is uploaded online? There was an image on one of the slides. And if you can answer that question for Cesarina, that would be great. And it looks like maybe Peter is offline at the moment. So Cesarina, I will forward that on to Peter so that I know that he sees it, and hopefully he'll email you directly with that information. And I think that's all the questions that we have. So I just want to remind people of two things. One is we have a new feature on our website where you can find a colleague, and this online session is great for doing that too, but you can put a profile of you and your research and what kind of colleagues you'd like to connect with, and it will appear on our website, and that's a good way of people getting to know other people in the field who are doing similar research and might be able to support them and collaborate with them. We have our RFA is due November 15th, so you've got a little over I think 3 weeks, and so if you're still looking for a collaborator for a project, you could check that out. It's just beginning, so there isn't a huge number of submissions just yet, but I encourage you to put yours on. And there's going to be a recording of today's webinar, and it'll take us a few days for us to put the recording up there, but you can look for it sometime next week. And here is the link for that. And I'll also send out an email to all of the people who are registered for this webinar, so you'll get that link directly. Okay, there is one last question, and we have some time, from Chang Lu Wang, a question for Mary Barbercheck. And does Metarhizium anisole strains become endophyte or different from the strains that do not grow in the plants? And Mary, if you are still online, I can make sure that you're unmuted. And if you want to answer that,
the systematics of Metarhizium anisole has changed a lot in the last 5 years, and there are Metarhizium anisole is actually a clade of 9 species, and so far we have detected 2 species, Metarhizium brunium and Metarhizium robertsi, and it doesn't seem like there's any difference between those two. Robertsi is where is the strain or the subspecies, however you want to call it, where this ability to grow endophytically was discovered. And so because we only have those 2 strains and they both infect, it looks like those ones are adapted to the disturbance that happens in agricultural systems, and they seem happy to at least infect corn. And so we have to identify these with molecular techniques. So we're building up our isolate library, and we'll be able to know which specific isolate or strain is infecting these plants.
Great, thank you very much. And so I'd just like to end by saying thank you very much to all of the presenters today who tried to, and I think actually succeeded very well in giving us some 5-minute summaries with 3 slides. It's quite a challenge to be brief, and I know that. And so I appreciate the effort that went into it. And thank you for making this possible. And if other people have questions for any of the presenters, please feel free to connect with them offline. And with that, I will declare this session complete and look forward to posting the recording for you in a few weeks.